Welcome back. Today we're doing a deep dive into a piece of tech that on the surface might sound incredibly niche,
Mm,
but it actually solves this massive problem in places like command centers or broadcast studios information overload.
right.
We're looking at the tvONE C2-6104A CORIO2. It's a four-window multiviewer, and our mission really is to unpack why a box that just displays four video feeds on one screen costs nearly $5,000.
It's a great mission because that price tag, it's the first thing that tells you this is not your average piece of kit.
Not at all.
What we have here is a dedicated 1RU rack mount device. The price right now is $4,975, and it's all built around their exclusive Core IO2 processing engine. That engine is, well, it's everything.
Okay, so let's get into that. Because if you or I try to put four video streams on a regular PC and start resizing them, it just falls apart.
Oh, yeah.
You get lag, dropped frames, the resolution tanks. But this box, it promises maximum flexibility with four sizable windows on a single DVI output. So what's the secret sauce here?
The secret is that it doesn't try to share resources. The architecture uses four, and this is the key. Four high-quality, independent scaling engines.
So one for each video window.
Exactly. The source material uses this great analogy. Think of it like four independent artists working on the same canvas.
I like that.
One artist can resize, zoom, or reposition their part of the image, and it has absolutely zero effect on the clarity or speed of the other three. That's what they mean by signal integrity.
And that's what you're paying for, that integrity, not just, sticking four pictures in a grid.
Precisely. In situations where milliseconds and image quality are critical, that's non-negotiable.
Okay, so getting those signals into the box. These specialized systems must use all sorts of different feeds, old and new.
For sure. And the unit is built for that. It has 5 fully HDCP-compliant universal DDI inputs, and universal is the key word.
Right, so that covers everything from modern DVI-I down to, composite and S-video?
It handles all of it, which is crucial for legacy gear.
But wait, you said 5 inputs, but it's a four-window multiviewer. Why the extra input?
That's one of the really clever design choices. That 5th input can be used for a dedicated background, like a static map or a company logo that's always on screen.
Okay, that makes sense.
Or, and this is huge for larger installations, it's used for cascading.
Cascading, you mean linking multiple units together.
Exactly. You need 8 windows or 12. You just connect the output of one unit into that 5th input of the next one. You can build these massive, perfectly synced video walls.
Speaking of complex, let's talk about resolution, because this is where I saw something that really stood out. The digital DVI-D input supports up to 1920 by 1200, 1080p standard stuff. But the analog DVI-A input supports up to an incredible 2048 by 2048.
Yeah.
How is the older analog signal capable of a higher resolution than the digital one?
That's a fantastic question because it tells you exactly who this device is for.
Mm-hmm.
Think about highly specialized equipment,
Mm.
flight simulators, certain medical scanners, industrial systems.
So they still use those non-standard analog signals.
A lot of them do, with very high pixel density. This box is made to handle those specific sources perfectly. And beyond just the resolution, the level of image control is microscopic. You get up to 10x zoom, and then you get into the real broadcast level features.
You're talking about things like chroma key and Genlock. For anyone listening who isn't running a TV studio, what do those actually do?
Okay, so chroma key is essentially green screening. It lets an operator overlay dynamic data seamlessly onto a live video feed. But Genlock is maybe even more important here.
Right.
It ensures that all 4 incoming video feeds and the final output are all running on the exact same internal clock cycle. It locks them together.
So it gets rid of any tearing or drifting between the different windows?
No vertical roll, no drift. It's absolutely vital if the output is being recorded or broadcast, or if someone's making a precise decision based on what they see.
And managing all this is, I assume, pretty straightforward for a professional user.
Oh yeah, you get 10 user-definable presets, so you can switch between complex layouts with one button. And you can control it all over a network using TCP/IP, which is how it's done in most command centers.
Got it.
And just a quick final note on the logistics. This is professional institutional gear, so it's non-cancelable, non-returnable.
You buy it for a specific job and it stays there.
Exactly. But it has a 5-year warranty, which shows it's built for a long service life. And you'll see discounts for education, government, and military accounts, its target audience.
So if we pull this all together, The C2-6104A is really a perfect example of a tool designed to handle extreme data pressure. You're not spending $5,000 on a splitter. You're investing in a guarantee that 4 separate, vital streams of information are processed with perfect, independent integrity.
That's the whole story. It's valuing specialized integrity over simple aggregation. And it leaves you with a pretty provocative thought, doesn't it? Well, if a device like this is needed just to properly manage 4 independent, high-resolution streams, it really makes you think about the sheer volume and complexity of data that organizations are managing every single day now.
Drone feeds, sensor arrays, surveillance.
All of it. And it raises the question, are we approaching an era where every critical decision point will need its own specialized processing architecture like this simply to keep up with the data that's constantly flowing in?